Now we're going to be looking at the heat treatment of polymers. Initially we'll be looking at heat on thermoplastics. My trusty assistant, Professor Kaidos here, is now heating up some high density polyethylene under a Bunsen burner flame. You can see the ends there have just slightly melted. If we take the same sample and give it a lot more heat now, so we're going to put it right in there in the roaring Bunsen flame, hopefully keeping not too much oxygen around there because it will catch fire. Okay, so we've given it a bit more there, and now you can see our piece of high density polyethylene is now melting quite easily. You see the edges of it have run and have gone clear. If we give it a little bit more heat, you see it goes quite clear. The crystallinity is now been lost, and we've got a sea of transparent polymer which is really quite flexible.
Keep pulling it with the fibres.
We've got a thin piece of low density polyethylene. You can see that almost immediately distorts. We've got a much thicker piece now, and you can see with a bit of heat treatment, unfortunately it does catch fire, but you can see the shape's been altered. Now PET, this is a polyester used in most plastic Coke bottles. And you see there that its shape has rapidly changed. Obviously a thinner piece of polymer is easily affected. I've got a much thicker piece of nylon 6. This will take a lot more heat. Now this is, once again, it's a condensation polymer. It's got amide links in it. It's got much stronger intermolecular forces in the case of hydrogen bonding, and we need a lot more heat to actually melt this. Unfortunately it does catch fire, and it's got fairly toxic fumes. That's why we're using a fume hood at this stage. You can see there that it's out melting and also disintegrating at the same time. If we give it a little bit more heat, we should really be able to melt it properly. So once again, even though it's a condensation polymer, it is still a thermoplastic. See there? And you can now see it melts quite well, and you see some fibres coming out of there. Now we're looking at synthetic rubber. This is once again an addition polymer. There's no cross-linking in this, so we should expect it to be quite plastic. It's also quite flammable, this one. We'll give it a little bit more of a heat under the flame. You see now it's started to melt. You see the shape's been distorted. It's no longer it's no longer just an elastomer, it's changed its shape. It's cooled down now, and you can see it's changed its shape. Now we're looking at a rubber band. Now this does have some cross-linking in it, only a little bit, but you'll see it's still quite flexible. I'm going to try and melt this a little bit without actually burning it too much. Now, we're not really sure of the amount of cross-linking at this stage, but cross-linking does stop things from melting, or they'd start to lose their thermoplastic characteristics as we cross-link polymers more and more. When we pull it out of the flame, you'll see that even though it's been burnt, there hasn't been any great distortion of the rubber. Now we're looking at our final polymer, Bakelite. This is a polyphenol. It's heavily cross-linked. It's a very, very heavily cross-linked thermoset. Thermoset meaning thermoheat. It's set, it doesn't move with any heat. So you can see it here, we're really giving it a lot of heat, and it's charring and even burning, but we can't see any melting occurring. This is characteristic of thermosets. In fact, this polymer Bakelite is used in Formica or Laminex bench tops, or even it's very similar to thermosets such as superglue and araldite, and typically they will not melt it at all. They will just burn or char if given enough heat. I'll give it a little bit more there to prove to you beyond any doubt that this stuff doesn't melt. My pyromaniac friend just can't help himself. He puts it back in the flame. Well, when we look at it up close, you can see there it's almost the same shape. The edges have burnt a bit and distorted, but we're still looking at a fairly square piece of plastic.